I take this height divided by the original drop distance height and take the square root of it, that magical little radical key on the calculator, and the end result is I get a COR. It's called a coefficient of restitution. Now, every sport has one. That's the miraculous thing. I can remember as a little boy playing golf for the first time with a ball that didn't look much like that, but it did look rounder like this. And when I took this ball, I remember my dad, of course, going to the ball cleaner. I said, "What are you cleaning that ball for?" He said, "You got to get the dimples clean." I said, "Why is that?" He said, "Well, that affects the flight of the ball." And I was kind of like stunned. How could a little dirt, for example, on the dimples of the ball affect the flight of the ball? The second thing he did was even more interesting to me. He took the ball and raised it, of course, to his head, and then he began to proceed to drop it. He let it hit on the concrete, kick back up, and he took the ball with the highest rebound height. I turned around to him, and of course, not knowing coefficient of restitution, I asked him what he was doing. He said, "What I always do is take the ball that has the biggest kick, because that gives me the biggest roll, the biggest, of course, drive, and everything else." So there was dynamical and physics reasons for taking the ball with a big kick. One of the great things about the sports module is the fact that you can really hook your students on it. One of the first things that you'll notice when kids come into a classroom is sports. Kids talk sports. And one thing you can do is finally integrate, in particular, mathematics and science into sports. For example, these units have closure on such mathematical fields as graphing, the use of calculators, the use, of course, of equations and equation studies, and, of course, the end result, developing some of the important parameters and variables in sports science. Another great thing about this is developing the observation skills. Kids get a chance for the first time to look at things in both a large and small plane and begin to see differences that really account for something. And if we're going to try to make great scientists, I think we have to develop that skill as well. Beyond all that, of course, is links with all kinds of other fields. Balls are made out of different materials, and materials are made out of atoms and molecules, and they traverse just about any field that you can think of. And beyond that, too, is the idea that these things link together to produce mysterious things like polymers that really develop, of course, the concepts of chemistry. When I look at, of course, this module, I see it a lot more than just a sports module. I see it a chance, of course, for kids to discover, to invent, to ask questions, and to take a look at things in greater depth than normal. And, of course, it's not just static like sometimes some of the classroom activities are. This gives a chance for cooperative learning and, of course, complements people working together to generate answers. And the beauty of this is that the answers, of course, are not known. And sometimes the answers are quite discrepant. So when students, of course, pick up this manual and they begin, of course, to take a look at the sports materials module, they understand that the process learning that they're getting is both iterative and constructive. And this makes for a very strong classroom learning environment. I recommend for teachers around the country that are trying to parallel some of the content of the curriculum, of course, and standards in their states as well as the nation, that this thing, of course, does a wonderful job of complementing them and meeting them at the highest level. The module, of course, matches many of the science and math standards and gives the opportunities for free expression and creative learning for your students.